Welcome to today's deep dive. You're watching a live game at home, and the picture's just, crystal clear. But think about the actual stadium for a second. How does a camera sweep across this massive field and send flawless high-definition video to a production truck that's parked, like, miles away?
Yeah, the logistics behind that are honestly wild. It usually comes down to very highly specific and incredibly reliable infrastructure. So today we're looking at product documentation from HDTVSupply for a device called the AJA FiDO-R-ST. It's a fiber to 3G-SDI receiver.
Right, so it takes a fiber optic signal and basically turns it into SDI video. I mean, serial digital interface, which is the standard raw video format used by broadcast gear.
Exactly. And it solves a massive physical problem, which is distance. This specific little $585 box enables a continuous cable run of up to 10 kilometers.
Wait, 10 kilometers?
Yeah, 10 kilometers. That is over 32,800 feet of distance between the camera and the truck.
Okay, let me just stop you right there. Look, why are we doing a conversion at all? I mean, if you need to run video 10 kilometers, why not just use standard copper video cables the entire way?
Well, because
It feels like we're adding an unnecessary, like, high-speed railed terminal just to get data off a fiber optic track and back onto street-level cables, you know?
Right, that is a great analogy, but there is a big reason for it. Because if you wrap 10 kilometers of traditional copper cable around a giant sports stadium, it essentially acts as a massive antenna.
Oh, like it picks up interference.
Precisely. It picks up ambient electrical interference from all the stadium lights, the giant scoreboards, the tens of thousands of cell phones in the crowd. Engineers actually call these ground loop problems.
So you end up with what, like buzzing audio or rolling lines across the screen?
Yeah, or just a completely dropped signal altogether. So the goal here is electrical isolation.
Electrical isolation, right. I see.
Because fiber optic cables use pulses of light to transmit data instead of electricity, they are, completely immune to all that environmental interference.
Okay, so the fiber optic cable acts like this interference-proof highway to cover the mile safely. But the monitors inside the broadcast truck, they can't read light. They need those standard electrical video signals.
Which is exactly where this receiver comes in. It acts as an off-ramp. An internal optical sensor catches those light pulses and translates them back into standard electrical video for the truck's monitors.
Right. And because this off-ramp has to live out in the real world, sometimes physically strapped to a moving camera rig, the physical design is almost as important as the electronics.
Oh, for sure.
Looking at the specs here, it's a compact, low-profile metal box that weighs just half a pound, and it draws a maximum of, 2 watts of power.
Which means you can easily tuck it behind an equipment rack or mount it directly onto a camera. It won't throw off the operator's balance or drain the battery rig at all.
And it's also doing a lot of heavy lifting internally without dropping any data, right?
Yeah, the documentation specifically notes that it passes through all the essential video metadata, so things like HDR are preserved, ensuring you get that incredibly rich color and contrast without any lag during the conversion.
Wow. And I guess live television doesn't exactly get a second take.
Never. The people building these broadcast rigs rely entirely on these rugged, unseen links. That is why broadcast professionals go to vendors with really long track records.
It's like HDTVSupply's 25-year history in the industry.
Right, exactly. And it's why a receiver like this comes with a 5-year warranty from AJA. The gear simply cannot fail.
Yeah, it really makes you think. Even if you never step foot inside a broadcast studio, the seamless live media you consume every day completely depends on this kind of hidden hardware.
It totally does.
So next time you see that sweeping stadium shot, think about the tiny translator making it all possible. Which leaves us with this final thought to mull over. If a half-pound box is the critical bridge moving high-def video across 10 kilometers of space, what other invisible, overlooked pieces of hardware are silently holding together the massive digital networks you rely on every single day?